Hi everyone, welcome to this meetup on implementing RAGs using Amazon BedRock. Okay, sorry. Today's session will be delivered by Suman Debnath, who's the principal developer advocate at the AWS. So Suman specializes in the machine learning aspects of AWS BedRock, AWS SageMaker, and he's been working with RAGs and vector databases at AWS. So before we get started with the session, I would like to give a quick introduction to Data Couch. So we are a professional training and consultancy organization that provides consultancy services, enterprise training services, managed services, and browser-based lab solutions in various cutting-edge technologies such as generative AI, blockchain, AR, VR, drones, streaming analytics, and many more. So to date, we have delivered over training in 75 different technologies, transforming the lives of over 150,000 participants across all the continents. So these technologies include names such as generative AI, big data, DevOps, cloud computing, and many more. We have a significant footprint in major 500, Fortune 500 companies, and it is growing by every day. Not only the number of participants that we are touching lives of, but importantly, our partnerships and our clients, that is also growing manifold. We are a firm believer in sharing our knowledge. So we boast of a vast knowledge sharing community, which comprises of 3 different meetup groups, that is AI Minds, Generative AI User Group Pune, and All Things Data. Together, we have over 15,000 members globally, and we have conducted over 200 meetup sessions like this one, covering more than 100 different technologies. Now to tell you more about our quality and our commitment to such enterprise trainings and our commitment to excellence. So we were chosen as the only global education partner of the year for 2023 by Confluent for our quality training delivery sessions. This is the second time we have received this award, the first being in 2022, that is the previous year. We were also chosen as the only global education partner by Starburst, and we are working in developing the entire academy platform for Starburst data. So there are different generative AI learning paths that are specifically designed for different personas and user roles. So you can contact us at hello@datacouch.io for more information. As you can see that these developer personas relate to developer, analyst, manager, executive, and different roles. And we also provide customized training delivery services for different other roles, not only in generative AI, but also all the other technology domains that we have. So I would like to hand over to Suman now. Suman, can you please start sharing your screen?
Yeah, sure. Thanks. So let me share and let me know if you are able to see my screen.
Yes.
Yeah.
I'll
Okay.
mute myself. Thank you.
Okay, perfect. Yeah, just give me a moment. All right. So, hello everyone. Thanks so much for joining in in the weekend. I think it's always great to talk to people and share whatever we are learning and learn from others in the community. So I really appreciate that you are taking time off during your weekend and attending this meetup. And if anybody is watching this in a recorded version, feel free to reach out to me in case you have any doubts going forward, or if you have any questions which is not covered in next 1 hour or so. Okay, so with that, let's get started. So what we are going to do today is we will get started with RAG. What is RAG? And intuitively, we will try to understand why this makes a sense and why it is important. And then gradually, we will get into the hands-on part where I'll show you a few of the code samples and a notebook which you can follow along. Maybe not during the session, but after the session today or in the days to come. And the code and the GitHub, everything, and including this presentation will be shared. And if you have any questions, queries, again, feel free to reach out to me. So that is more important than following along. All right, so I can see the chat window. So in case you have any questions, feel free to ask that, and I'll be more than happy to answer that. Okay. All right. So we all know that machine learning is has been touching everyone's life predominantly in last 1 decade or so, and with the emergence of cloud computing, a plethora of data, and a cheaper resource. And especially with the large language model these days, it has been injected in a very massive way. So intuitively, we all are using machine learning in some other form, even if we are not realizing it. So we are actually using it, whether it's a mobile phone, shopping, ordering something at any of the companies like Zomato, Swiggy, you name it. So machine learning is powered by all of these applications. And it is still in an inflation point where we are still going upwards from now onwards, and the rate and capacity that we are getting the technology is growing in an exponential rate, right? So this is a good time to learn and make use of this in our work in a more productive way. To be frank, I was just talking to one of my friend yesterday, and we were discussing that uh, when we started our career, my background is from system. Before I got into machine learning, my background was into storage and systems, to a very specific storage area networking. So if you know about distributed systems, so I was telling my friend that when we started our career on those were the technology which were there for last 50 years or 40 years. But now what we are having in machine learning is everything, whatever we are working on now or trying to learn, these all have come in last 5 or 6 years, or maybe maximum 10 years, if I just take a elongated time period. So it's very easy to get overwhelmed, but at the same time, we need to be consistent and keep ourselves updated, and keep learning it without thinking that okay, whether we will be able to complete something given the time period that we have. Okay. All right. So I will just skip through this, but one thing that is very obvious is that generative AI has changed everyone's life in some other way. We can now create different content. We can create images, videos, stories, and all that. You might have seen ChatGPT and other applications like that, which was kind of unimaginable, at least 3-4 years back, and 10 years back. No one have ever thought of that. So we have to appreciate the fact that how this has evolved. Now, as a machine learning engineer or as an engineer, you can choose two paths. Okay, so one is you use all these models to build something very smart, right? Or the other side, where you want to get into that domain or area where you will try to get yourself involved in building those models, right? So there is a black box, which is kind of the model that you can think of. And on the left hand side, it's the user, which has a massive use case, right? If you are a software engineer or business analyst or anyone, any domain, you all can make use of this model. And then on the right hand side are the machine learning engineers, scientists, and then applied science people who are actually working on building those models. So you can pick your path depending on your background, but the fundamental fact is this area serves something for everyone, right? So today, since we are focusing on more on the machine learning side, let's first understand what is the difference between a generative AI model or large language model and a traditional machine learning model. So if you think about it, a traditional machine learning model previously it is still in use. Uh, we used to have some training data, along with its label. And the data and the label is very much specific to the problem that we had in hand. So let's say we want to build a model which will just generate text. So what we need some text data for that, right? So we will create a model which will just generate text. Then let's say we have another problem of text summarization. In that case, we will create another model which will do just text summarization. Similarly, Q&A, chatbot, and all that. So we always have to have labeled data. So when it comes to summarization, the labeled data would be, let's say, a news article and its summary. Then another news article along with its summary. And after that, we use different algorithms, different machine learning algorithms, techniques to come up with a model which generalizes, right? And that's how we used to have different models for different problems. Now, this works fine, but if you think about it, it's not very scalable, right? So for different problems, you have to come up with different models. And for different models, you have to have different set of training data. And those all data are labeled data in general, right? So now the fundamental difference between that and a foundational model is this. So now you don't need a different data set. So you can have a plethora of data. So when we say foundational model, it covers uh, text generation or data around text, images, and videos and all that. But for today's discussion, let's consider just text. Okay, so that's why when you think about when people say large language model, that's mostly referring to the text-based model. But when you think about any model which can serve or which can solve problem not just on text, but also image generation, video generation, and all that, we call it as a foundational model, right? Because it's not just text. Okay, so now in text, what we now would do is we will take a lot of data completely unlabeled. It's not labeled at all. So the way that you can think of it is, let's say a Wikipedia data or every piece of data that is available on the internet. You use that data to build a model, right, which is the large language model or the foundational model in this case. And that model will be able to do different tasks, right? So whether it's a text generation, summarization, Q&A, chatbot, you name it, right? So the way that you can think of it is like this, okay? I'll give you an example. So let's say uh, uh, I have a kid, right? My kid is 6 years old. Now, if I tell him that uh, that yeah, if you can go on mute, yeah, thanks. So let's say if I tell my kid that, okay, tell me, Rayan. So Rayan is his name. So if I tell him that, okay, Rayan, there is a fire on this floor. And if I just ask him, is it a good thing or a bad thing? So what I'm essentially trying to ask is a sentiment analysis, right? Is it a positive sentiment or a negative sentiment? So he would say that most likely that he would say that yeah, it's a bad thing, so we should run away from here, right? But if you think about it, why he was able to give that answer is because he has a basic understanding of language, right? Whether it's English, Hindi, Bangla, whatever it is, he has a basic understanding of language, and his understanding of language is so good that he was able to infer different questions, right? So although he was never given any task like this in his school or college, right? So that means it was now if you want to translate that into our discussion, uh, the way that foundational models are trained is basically we are training a model such that it should learn about English or Hindi or whatever language that we are thinking of, right? And if we understand a language at its very core, then if I ask you a question, you will be able to generate one word at a time, right? Or you will be able to generate some answer. Like I'm talking now. So what I'm essentially doing is I'm just speaking one word at a time, right? I'm just generating the text. And the way that I'm generating is just by my intuition and my understanding of the language English. right? So foundational model is nothing but we train a model. The core idea of that model is to understand the language. That's all, right? Because the assumption that we are making is once you understand a language, after that, whatever question comes in, you have learned that language with lots of data, right? Unlabeled data. It doesn't matter what data it is, but I will be able to give you the answer. So today, if you go to ChatGPT or any of the large language model and ask a question, 2 plus 2, it will give you an answer 4, but it doesn't know actually intuitively. I mean, at its core, it is not doing any mathematical operation that 2 plus 2 is 4, but it has learned it so well, like with lots of data, that he knows that, okay, with 2 plus 2, it should be 4. So it's not doing any math as such. Okay. So now I will just skip this slide. This is not very important. Towards the end, I will just show you what generative AI is on AWS. But the topic is today RAG, right? So let's jump into that. So now you have a model, a large language model, which can answer any of your question, right? But let's say you have some question like this, like which are the products got the best review on your platform in last 15 days, right? So let's say you own a company like ebay.com or amazon.com, and you are a product owner for that, and you want to know which product got the best performance or best review in last 15 days, right? If you ask this question to any of the large language model, it will not give you the right answer, right? Because that model doesn't know your present data, because the training has done a long time back. Because when we deploy a model, we complete the training and then deploy. So most of the time, the model has been trained till a certain period, right? So let's say the model was trained till the data that was available on the internet till December 2023. So if you ask anything on about any news or anything which is very recent, let's say which happened, let's say in our election just last week, it won't be able to answer, because that data has not been used during the training time. Similarly, if you ask some relevant question like this, right? In this case, this is a recent match, who won the India and versus Afghanistan match in T20. It may not be able to give the answer. And the reason is the knowledge cutoff, right? So it won't be able to get the real-time data. And second is the first question which we asked, what are the best reviews of our product on our platform in last 15 days? It will be able to give you some answer, but that answer will not be accurate, right? So it will just give you the answer of some of the products which got the best reviews, but it will not give you the best product review in last 15 days. But it can just give you some hallucinated answer, right? So it will just do a guess. So how we can solve this? Because these are the limitations of any large language model or foundational model, right? So now the task is how we can make use of large language model along with something which can help us to answer all these questions. And the problem that we have at this point is two things. One is knowledge cut, and second is hallucination, right? So before we jump into the solution, let's see how these models were trained, right? So we talked about it a while back, but let's quickly go over this. So let's say we have the entire internet data, and we take all the data to train a model. And these all are unlabeled data, right? It's just the text, that's all. And then once the model is created or trained, then we can ask a question. So we also call it as prompt. And it could be any question of your choice, right? Something like, let's say, explain thermodynamics to a middle school student, and it should be able to give you the answer, right? So this is how the any foundational model or large language model is trained. Now, this is not working for us, right? So we need to do something, right? So this is not working for us, so we need to do something. So how we can do that? So we need to customize this model, right? So let's see what are the techniques that we can customize, right? So the first thing that way that we can customize is using fine tuning. So what we can do is we take any of the large language model that is available from various companies, various AI startups, right? So you can take any of the foundational model, and then on that, you use your data, which is relevant to you for your organization. You use your data to fine tune that model. So what happens? You in fine tuning, you have that model, and it has. I mean, if you are from deep learning side, or if you have learned a little bit around deep learning, these models are nothing but deep neural networks, right? And then what is happening is, in this network, in this foundational model, we have lots of layers, and it has lots of weights and biases, right? There are lots of weights. Like, it's when you read any paper and it says that it has 1 million parameters, so these are nothing but 1 million weights and biases, right? These many numbers are there, basically. Now, when we say fine tuning, what we essentially say that in that neural network, we will not change the weights of anything, but we will add few layers towards the end of the neural network. And those layers will help us to fine tune my model for my data, right? So now this is a good technique, but this needs a lot of effort, time, and understanding of little bit of machine learning, right? So you need some expert in machine learning to do that. But once you fine tune, that model will be yours, right? So you can deploy in your account, and then you can make use of this. So this is one good use of customizing your model. But in this case, one important thing is you need to have a large amount of data, right? So because otherwise this model will not be fine tuned, that effectively. Okay. Another way to do that is continuous pre-training. So this is similar to fine tuning, but here in this case, you will not need labeled data. You can do it with unlabeled data. And that's why we say continuous pre-training, because this model, the pre-trained model, was trained on unlabeled data. And now what we are saying is you just continue the training with your unlabeled data. Okay, so in fine tuning, you need labeled data. That means data along with your label. And in this case, you just need to pass the unlabeled data. Okay, so one example of fine tuning would be, let's say you are a legal firm, and you want to create an application which will summarize your client's information. Now, it's a text summarization job, but in that case, your data is very different than the data which is available generally in the internet. So your labeled data would be your client data along with its summary, your client data along with its summary. So once you fine tune that model, after that, when you give your client's data, it should be able to summarize in a more legal way, or in a way that language resonates legality, right? So this is an example of fine tuning. Similarly, in continuous pre-training, you just continue the training without the label. And the next one is RAG. So if you think about it, the first two demands a lot of data. And I mean, you can do the fine tuning or continuous pre-training in a very small amount of data, but that may not be that efficient, but this needs some expertise on machine learning, little bit of expertise in machine learning, right? And you need money and time to train that model and deploy that model. So that's why RAG, or retrieval information, is very useful. And today we are going to discuss this. So what is this? This is very simple. So what you do is, previously, you had some question, you used to ask the large language model directly, right? Like, let's say, what is the best product which got the best review in last 15 days, right? This was the question that we asked. And the model was not able to give the answer. But now what we are doing is, we will not ask this question directly to the model. What we will do is, we will first store all our data, our personal data, right? So let's say if we are a product manager of Amazon.com, or let's say eBay.com, or any of these companies, and we have the data, right? We have all the customer review data in our database, right? So what we would need is, we need to somehow store that data in a certain format, and that is what is called embeddings, and we will get into that in a while. But we will store it in a database, and then what we will do, when you ask a question, you will not ask the question directly to the large language model, but you will ask the question to that database. And from that database, you will get some context. So it will just give you, take this chunk of data, this chunk of data, and this chunk of data. And these are kind of a semantic search, right? And then we will take that question and we will take that context and then give the question with the context to the large language model. So now the large language model will be able to give the answer, right? So one example would be something like this. So let's say I have, let's say I am a librarian, okay? And I have some book. Let's say this is a Python book, right? And this is another book on machine learning. So let's say I am a librarian. So I will keep all these Python books and programming books in, let's say, that corner of the room. And let's say I have some books on physics, and that I will keep it in that corner of the book, right? And now, let's say you have come to me and you ask me a question that, okay, Suman, can you tell me what is, let's say, let's pick something. You ask me, what is an array and how we can define an array in Python? So I know that you are asking a question around programming and Python. So what I will do is I will go to that corner of the room and I will get that few of the Python books and I will give you these Python books and I will tell you that, okay, in this book, chapter 1 and 2 covers something which I think should be able to give you the answer. In this book, read page number 10 to page number 20. It should give you the answer. So you carry all these two books and basically two chapters along with you. So now what I have given you is the context. And this is what you this retrieval in the RAG world, this retrieval does, right? It will just give you the chunk of the data. And now you have your question and you have the chunk of the data, right? Now you should be able to use the large language model to get the answer. Okay, so we will get into that once we see that in the code, as well as we'll dive into this next. Okay, so before that, let's see what is vectors, because all these large language model or these foundational models, to work with them, we have to convert our data into a format which they understand, right? Because if you see here, at the end of the day, we have to ask the question to the large language model. And large language model doesn't understand plain text, English, Hindi, or any language. We have to convert all the data into the form of vectors. Okay, so let's see how it is done. So we have all learned in the elementary physics and math class that a vector has a magnitude and direction. So in this case, we are not that much concerned about the direction. But let's say how this works. Let me give you an intuition. So it's basically an array of numbers, right? So let's say this is, so this is not a very good example, but the way that you can think of it is, when you give us a text, we just convert it into an array of numbers. That's all. As of now, you just keep this in mind, and we will break this through, as we progress in the session. But the way that you should think about it is, whenever we have some text, we just somehow intelligently convert that into an array of numbers. That's all. And there is a certain length of this array of numbers, right? There is a certain length of this array of numbers, and we will see that in the code, and we will also see how these numbers look like. Now, this is basically called vector embeddings. Okay, so when you convert a text into an array of numbers, is nothing but called vector embeddings. Okay, it's basically a numeric representation of your word or sentence. Okay, so why we need this? Because this will help us to do some semantic search, and we will get into that in a while. So let's see how this will work. So we will have our data. It could be document, image, or text, or video, audio, whatever. We have to first convert that into an array of numbers. And how we will convert that? We will use some embedding model. So what this embedding model will do is, it will just convert your data into an array of numbers. That's all. Now, what model we should use? There are different techniques that different models which are available before this large language model era, like in 2000, early 2000, we had a lot of techniques, classical machine learning techniques like word to vec, then glove and all that. In fact, today, we don't use all of them. We used a certain large language model to just convert the data into embeddings. Okay, so we have models like Cohere, we have models like Titan embeddings. What they do is they just convert your data into an array of numbers, right? So first thing is we have to convert the data into an array of numbers. So once it is converted, you will have your data in the form of numbers. That's all. Okay. After that, what we have to do, we have to store this data somewhere. So we will use a vector store. So this is a very different database than a relational database. In this database, we store the data along with its embeddings, because we have to keep the data. We cannot just delete the data, because at the end of the day, once we have the embeddings, at some point in time, we have to convert the embeddings back to the data, right? So we should we should save the mapping between the data and its embedding. So that's why we need a vector store. So once we have the vector store, we are good, right? So we are done, because this is what we needed to get started with anything with large language model, right? So at this point, I have my vector database, and imagine that in our previous example of that e-commerce company that we are owning. So let's say we are a PM of Amazon.com.
Okay.
Yeah. Anybody have any questions? Okay. So if you have any, if you have all of your data in the vector store, so let's say I'm a PM for Amazon.com. So I have the data for all the products, all the reviews in this vector store, right? In the form of embeddings. And this vector database is keep on updating, right? Because every day somebody is adding a new review of my product. So it will be added into the vector database. So it is a continuous ingestion of the data that is happening, maybe per day basis, per week basis, or whatever it is. So now, when you ask a question, we will not ask this question directly to the large language model, right? Because if you are able to get the answer, then why we have to think about all this RAG and all this fine tuning, pre-training and all that drama, right? So we are trying to solve one problem. So that's why we came across, I mean, we have done all the hard work to convert our data into vector store. So what we will do, we will not ask the question directly to the large language model because we were not getting the answer. So now we will ask the question to the vector database, okay? And then vector database will give us some context. So this is exactly what the example that when we gave when we discussed that you asked me a Python question and I gave you a few books and I gave you that, okay, in this book, read chapter number 1 and 2. So you can think of this green box as chapter 1 and 2, this purple blocks, maybe another books, let's say paragraph 5 and let's say page number 4, paragraph 3, something like that, right? So these are the context. This is not your answer, but you just collected all the context. So once you have this context and the question, now you can send it to the large language model, right? And when you do that, you will get a better answer. So it's like I ask a question, okay? Let's say I have a question on, let's say, history, okay? And to a professor who is a professor in linguistics, right? He doesn't have any understanding of history, but I asked him a question and I gave him few of the books which is around history, and then ask a question. So that professor, which is the large language model, since he or she knows English very well, he or she will be able to get the answer by reading those books and connecting it with the question, right? So that's how the whole thing of a RAG works. And who does all this activity, like talking to the vector database, getting the context, then sending that question along with the context to the model? This is done by different frameworks. There are a lot of frameworks available, and one of them is LangChain. But you don't have to use LangChain, but this is one of the way that you can get started. Okay, so that's how the whole things work. Now, what we are going to do now and next is we will get into the code, and we will try to see how you can create a vector store, how these embeddings look like, and we will build some application. Okay, so if you have any questions, feel free to ask, but this is the intuition. So can you just on the chat, do you feel that it makes sense? Are you able to follow along, or because after this, once we jump into the code, you will get a better understanding. But let me know if anything is not clear till this point so that I can repeat. Okay. All right. So let me. Okay, before that, I just have a small. Yeah, let me just play this and then I'll jump into the demo. Okay. So this is a quick demo of just 1 minute. Okay. So I'll tell you what this is going to do. Okay, so one of my colleague, he writes newsletters I think he writes newsletter every week or every month, I guess, and then he collects the newsletters from the open source community. His name is Ricardo. He's the open source expert in our team. So he writes open source newsletters every month. Now I had some question around some latest thing what is happening in open source world. So what I have done is I have taken all his newsletters and converted into embeddings and store it in some vector database. And then I'm going to ask some question. And when I ask some question, I can use any of the large language model. And the expectation is it should be able to get the context from all the PDFs of his newsletter and get the answer for my question. Okay, so let's see this. So if you see this here, we will first upload the newsletter. So this is the PDF which contains all the newsletter. And now we can ask some question. If you see this question, who are the top open source contributors, right? So if you see the answer, these are the latest open source contributors. Maybe this was in 2023 December timeframe. Now let's ask some other question. When is open source conference in India happening? I think that is the question I asked. Yeah, when is the open source conference in India scheduled? Right. So this is a very latest event when I did this demo. And if you see this, the answer it is giving us is the date of open source India conference is October 12th to 13th at Nimans Convention Center in Bangalore. Right. So I think this demo I did in the time frame. I mean during that time frame, October or September. Okay, so that's the beauty of a RAG, right? You are able to ask question which is very recent. Like imagine today, if you go to any of the large language model and ask a very recent question like who won the T20 match between US and Pakistan, it may not be able to give you the answer, right? Because this is a very recent activity. So now let's get into the bedrock part. Okay.
Suman, hi. There's a question from one of the participants, Prajot. So
Yeah.
he asks, will the context have entire sentences from the books or only the words similar to the query? Words versus sentences. So that's
Correct.
basically the question.
Yeah. So so this is where we will show now, but the context will not contain the word. The context will contain the whole chunk. And what would be the length of the chunk that you can decide. So it's not always just the word, because only word will not make much sense. You need a full context. And there is a context window or context size, but it's mostly, it's always a chunk of text. And we will see that. Okay. Okay, so there is one question I see here as well. So Ravi is asking, can we focus on bedrock? Yeah, of course. Now only we will focus on bedrock. The reason that I focused there a little bit more is because now it's in bedrock is just an API. You will be amazed to see that how easy it is to get started. Okay, so it's nothing in bedrock to say we have. Okay, so now let's see how the everything works. Okay, so what we will do now is we will create an application which will do something. So what we will do is we will take any YouTube video, and then we can ask any question, and the question will get the answer from that YouTube video, right? So this is something that this notebook is kind of I got motivated by one of the tutorial of Santiago. So I will share this notebook. You can watch his YouTube video on this. He has used a different database and all that, but I've used BedRock and I've added few of the other things. So I will give you the GitHub repo, which contains a few other notebooks as well. And then you can follow along this introduction to RAG. Okay. Okay. So let's see how this works, right? So first thing, we need a database, right, to store the vectors. So I have used a vector data store called Aurora. So Aurora is not a vector data store. Aurora is a relational database. So if I see Aurora, right? So this is a database that we have. It's a relational database, but it supports different engines. So one of the engines that it supports is Postgres and Postgres. Oh, sorry, MySQL and MySQL, Postgres, and all that. So different engines it supports. So I have created a Postgres Aurora instance, and in this Postgres there is an extension called PG Vector, which enables Postgres to store data in the form of vectors, right? So you can use Aurora Postgres database as a vector store, right? There are different vector stores available on AWS, but I'm using Aurora, right? So it's pretty straightforward. So what I've done is I've just created one database. So if you want to create, you can just click on create database and see this. There are different engines that are available, MySQL, Aurora, and all that. All you have to do is you just have to click on Aurora and give some username, password, very standard thing, and then scroll down and click on create database. That's all. Okay. So I have done that. So this is the first requirement because we need to store our data into a vector database, right? Our data. So in this case, our data would be this YouTube data. So what we will do from the YouTube, we will somehow get the transcript of that YouTube video. And then this data, we need to store it in an embedding, right? So in a vector store, that's what we will do. So first thing first, so what we will do first is we will just load the environmental variables because this contains the username, password of my Aurora database and other credentials. Okay. So now let's see how we can build this application. But before that, let's see how we can use BedRock. So BedRock is a service on AWS which offers you the flexibility to use any model of your choice, okay, which are supported by BedRock. And you don't have to use different APIs. It's a single API. You just change one line of code and it should work. So the way that you can use BedRock is something like this. First, let me show you in the UI. So this is BedRock. So you can select any region of your choice and click on Get Started. And this is the welcome screen that you will get. So first, what you can do is you can see there are a couple of things, chat, playground, text, image, and all that. So this is the base model. And if you see this view, you can see that all these different models are available for your use from different companies, right? Anthropic, Cohere, and all that. Now, let's say you want to use any of this model. All you have to do is you can use some, let's say, a playground like chat, and you can select any model. So let's say you come to Anthropic and select, let's say, Claude 3 and apply, right? And then you can simply ask the question of your choice, right? So let's say, what's the capital of India, right? So you can ask this question. So this is, not a big deal, right? So there are a few parameters that you can give, like top K, top P, and all that. Maximum length, like how much, what should be the length of your response. So because these things matters in when you pay the bill to AWS, because the way these all are priced are based on tokens, right? So basically, how many tokens that you send and how many tokens that you get is something that we charge upon. So how do you know how many tokens that we have? So let's say this is, I just copy this question, okay? And there is a tokenizer. This is a TikTok tokenizer. And this is a nice website to see how many tokens your sentence contains. So this is using a GPT tokenizer. You can use any of the model just to give an intuition, right? How this sentence gets divided into tokens. So if you see this sentence, which has 1, 2, 3, 4, 5 words, it comprises of 6 tokens, right? These are the token IDs, and every ID is then converted into an embedding of very huge array of numbers, right? So, and we will see that in the code in a while, right? So these are the things that we have in what is that in your embedding layer. Okay. Okay. So these are the things that we have, and also there are few configurations
Suman,
yeah.
sorry to interrupt. So there's a specific question which is related to this context only. So
Yeah.
Ravi is requesting, can you please explain top P and top K in that model?
Right. Yeah, we will get to top P and top K. Because for that I have to explain you a few of the ways that how this text is generated. Okay, Ravi. So I'll explain that top P and top K. Okay. So basically, what these are basically probability distribution, because what happens is in top K, at the end of the day, what these models are doing is it is generating a distribution of tokens, right? So it is nothing but at the model level, the large language model, what it predicts is one word at a time. Okay. Now, from where it is getting that one word, it is getting the one word from the vocabulary that the model has. So for example, let's say for the simplicity, let's say my model has a vocabulary of 1000 words. That means every time I ask a question, it will generate the answer, and that answer comprises of, let's say this answer, right? It comprises of how many words? 1, 2, 3, 4, 5, 6, 7. So let's say this comprises of 7 tokens. Okay. Now, the first token that it has generated is the. So that means the was there in its vocabulary, right? So what this top K says is that when you pick the word distribution, when you pick the word, pick the top 120 tokens from that 1000 tokens. Because at the end of the day, the model generates a distribution. Okay. Every time it generates a distribution of that 1000 words, which it has in the vocabulary. From that 1000 words, we have to pick something, right? We have to make a mechanism to pick the right word. And these configurations like top P and top K actually controls what output that the model should predict. So top K, when we say 250, what we are essentially saying is that, take that top 50 250 tokens from that whole probability distribution. Okay. And top K is basically what we are saying is within that 250 tokens, I have to pick the top tokens which is within the 99 percentile, so which has the highest probability. So if you reduce this, you will see the more randomness, right? So this is if you have to little bit we have not talked about how these embeddings work. If I have explained that, then it would have been easy. But the way that you should think about intuitively is something like this. So let's say you are a kid and you have a lot of candies in your bag, and each candy has some sugar level in that, right? So let's say one candy has 80% sugar, another candy has let's say 90% sugar and all that. So when I pick one candy, and if I have set a threshold that, okay, I will pick the candies which have more than 90% sugar. So even if I have 10 candies, my search space is just 2 candies, right? So the way that you can think about it is like that. Okay. And I think Sarfaraz asked a question. who converts that text to embeddings? This is where we have to use some model, which can, any large language model or any classical machine learning model, which will convert your data into embeddings. And if you see this here, in the base models, if I show you here the modality, and you will see that there are a few models which we are going to use in our demo, which are just embedding models. And what it does is it just converts your data into embeddings. It doesn't generate any answer or response. It just converts your data into embeddings. And you can use different embedding models like Titan embedding models or Cohere and so on. Does that make sense? Okay. Okay, great. And we will explain, top P and top K even more detail. Maybe I have a session after 2 weeks on tokenizer. In that, we will go in the very depth of how this random, continuous probability distribution happens on different tokens and how we pick the top P and top K. Okay. All right. So let's go back to the code. So we have seen how it works in the UI, right? It's simply you can come to the playground, select any model of your choice, right? Select any model of your choice and ask questions, right? So it's nothing much here in on BedRock, and that's the that's the reason I it's if you know how large language model works, how generative AI works, or RAG works, using using BedRock is no big deal. Okay. All right. So let's go back to our code and see how we can use BedRock from our code. So I'm using LangChain. So this is the framework. If you remember, where is that? If you remember here in this architecture, I think this one. Okay. Yeah. If you remember this, we will be using LangChain for talking to the vector store and the large language model, right? So that's why everything is using LangChain, but you can use the AWS default or not default, the Python SDK, which is Boto 3, okay? You can use this as well. But we are not going to use that because here we are not only using AWS service, but also the vector stores and other things, and we are connecting different dots. So that's why we will use LangChain. So here we are creating a chat. We are importing this module, chat BedRock, and this is a latest version of LangChain. So if I have to see that, what is the version? Okay, so let's see. I think this is the latest version. Yeah. So if you are installing LangChain, make sure that if you're following this code later on, make sure that this is version 2, because in version 1, they have done some package restructuring, right? So a few of the imports will not work. All right. So first we will import chat BedRock. And yes, Nikhil, this notebook you can run it locally. The only thing that we have to do is you have to have AWS account and your AWS CLI is configured. Okay, that's all. Because when you run this, right, when you run this line of code, it would go to BedRock and it will search for this anthropic model, right? So you need to have the AWS access. And that's why we actually loaded all the environmental variables. And here only we have all the configuration set for access for not only for AWS, but also for the database, like in this case, Aurora. Okay, Piyush, does that answer your question? Sorry, Nikhil. Okay, so I think Piyush is also asking, can we use fine-tuned model with BedRock? Yes, of course. And I will show you that as well in fine-tuned. Okay, so let me finish this and then I'll show you a fine-tuned model as well on BedRock. All right. So first, we will just have to give the model name. And if you see this, here we have to give the arguments. These are exactly same arguments that we have given here, right? The temperature, token, top key, and all that. So same things you can give as part of model keyword arguments. That's all. And then we can ask some question. So in LangChain, we have a messaging API, which will structure your question in a better way. So that's why we are using human message, but you can actually omit that. And I'll show you why I say this. So the way that you have to send your prompt is just you give your question and then just say model.invoke and your message. That's all. And this is in the previous version. I think in the latest version, you don't have to use human messaging because it will by default use that. By default, it will use that. So let me show you what I mean. So let's say if I just say, let's say this is my model, right? So model.invoke. And if I simply ask this question directly, okay, if I just simply ask this question, it should be able to give me the answer. Okay. So see this, it's the same answer that I got, right? And if you see this, the answer, the response that I got is an AI message type, right? So it is a object of AI message and it contains the answer in this hash called content. And then it also gives some, other information or the metadata about this query, like which are the additional parameters that I have used, what is the prompt token number, like size of this token. See this, the prompt token is 20, right? So that means there are 20 tokens. And we can actually check this. Let's say, let's copy this and paste it here. And let's see what is the size of this, right? So if you see this, this is, I just copy this embeddings and token IDs. And I can just say len of this, right? So it is 12. So it is not same. And the reason it is not a same is because here we are using a different tokenizer. And here it is using a GPT 4.0. But you get the idea, right? So what these numbers are, because here we are, this is not using the GPT 4 tokenizer. So that's why it is not exactly 20, exactly 12. Okay. In this case, it is just 20. But anyway, so you know now how you can invoke a question and how you can get the response. But this response is an AI message. This is not very useful. I need to have only the answer, right? So we all need just the answer. So how we can do that? So we have something called parser, and gradually you will now understand why LangChain is so important and how why it is so useful. Okay, now you will gradually get the intuition. So in LangChain, we have something called output parser, and there are different output parsers that we have. One of them is just string output parser. What it does is it just extracts the string from this AI message. Okay, so let's see how this works. So I will create a parser called string output parser, right? So this is the object I've created from this method. And then I'm creating a chain. And this is where things gets very interesting. So now what I'm creating is I'm creating a chain. So what this chain will do, it will take the question, it will give it to the model. The model will give you the response, but the response will not contain only the text, right? The response will contain all this message along with the metadata. Now I'm telling using a parser, which will just extract the answer from that, and then it will give you the result. So the sequence is model and then parser, right? So that's why my chain contains first model, and then I'm giving a pipe sign. So that is how you create a chain. And then we have the parser. That's all. Now we are not, previously, if you remember, we used this, right? Model dot invoke, right? We use this, and then we gave our message, right? This is where our question was, right? This is how we have parsed this question. But now we are not doing this, right? So we are not going to do this. So what we are going to do now, we are going to invoke on the chain. So in this chain, this question will go to the model. The model will give the some response, and that response will go to the parser. And the parser is what we have defined as string output parser. So it will give us only the text, and that's how you get only the text here. So you can always do this of your own, but you have to write a lot of code to just do the string parsing and all that. And this contains not only string parser, but it also contains parsers like HTML parsers and all that. So if you see this, let me show you this. Let's say import import as OP, right? And then if you see OP dot, and see this. You have a lot of parsers. You see this. I think there's a JSON. No. Yeah, so there is base LLM output parser, there is base output parser. There are a lot of parsers. There is simple JSON output parser. Here it is. There is a markup down parser and so on. So we have used just the string parser, right? So you get the idea. So now, now that we are able to use this chain, let's see what else we can do. Now you can think about our RAG problem where we have a question and some context. So let's see how we can create some such template, right? So in this case, we have not yet come to RAG yet, but we will gradually go there, okay? So here we are going to create a prompt which contains some context, right? So if you see this, this is the context and this is the actual question. So in this case, I'm just creating two variables, right? So this is how I create a template, prompt template using LangChain, okay? And what I'm saying is here, I'm just creating this text and it contains context and question. And these are the two things which I will give to the prompt. So in this case, if you see this, I've used chat prompt template from template, and I'm giving this template. This can be your customized template. And now I can format this template with my context and my question. And if you see this, if I print this response, I have not yet sent this question to the large language model, right? I'm just formatting the question, how the question should be asked to the large language model. And if you see this, it has exactly same text, what we see here, exactly same as the template that we have defined. The only thing that it has done is it has replaced this context and question based on my context and my question. Okay, so Rashmi is Rayan's mom, who is Rashmi's son. So this is the question that we have. So this is how we can create this prompt. So now let's see how we can use this and connect to our chain. So previously, we just had our question, and then we used to send it to the model and to the parser and get the result. Now, let's say we need to have question and the context. So we have to first generate the prompt in our way. So this is what we will do now. So we will now create another chain. Previously, the chain contained only model and parser, but now we have prepended, we have added prompt in front of that, right? And the prompt is nothing but what we have defined here, right? From this template. So now let's see how we can invoke. So in this case, now we are just saying chain.invoke, and this invocation is happening with this context and this question. So this context and question will go to the prompt. Prompt's output will go to the model, and model's output will go to the parser, and then parser's output we will get, right? This is how we are building the chain. And if you see this now, it is saying the response that we are getting is based on the given. So this response is coming from the large language model, right? Which is Claude in our case, from BedRock. So we are based on this question, based on the given question, Rashmi is Rayan's mom, and the answer to this question is Rayan, right? So you're getting the intuition how we can use LangChain to build a chain, from scratch. So similarly, now let's make this little more interesting. So now we will add one more thing to the chain. So let's say we ask the same question, similar question, but now we want to generate the answer in a different language. So now we are adding another prompt, which will take the answer and it will convert into a different language. So till this part in this architecture, if you see this pipeline, it's exactly same as before, right? We take the question, we take the context, generate the prompt, send it to the model. Model will generate the answer. Now, we are not happy with this answer. We want to convert that answer into a different language. So let's say Hindi, right? So now we have to create another pipeline where we will get this answer, and then whatever language we want, we want the answer to be in, we will use that language and then use another model to convert that into that language and get the answer, right? So let's see how this we can build this. So at this point, we have created this chat prompt, right, which will take the answer and the language, but the answer will come from this chain, right? So the answer will come from this chain, whatever is the answer from the large language model. So if you see this, this is the result, right? This is what the answer would be, and to the language, whatever language that we have. So now let's create this translation chain, which will take, see this, the parser model and translation prompt. So this is the change that we have done, right? So it will first get the create that chain that we have defined, right? This will give us the answer, and from that we will just take the language, whatever language that we want this to convert, and then it will just, this part is pretty straightforward, right? We get the answer back, final answer with the changed language, and then the output parser. So in this case, we have three inputs, right? Question, context, and language. And that's why when we invoke, we give question, context, question, and language. So the question and context will go to this chain, right? And from this chain, whatever is the output, we will take that, and we have to know the language. So the language and the answer, both of them goes to this translation prompt. And that translation prompt, what it does, translation prompt, if you remember, translation prompt takes this, right? Translate whatever is the answer to this whatever is the language, right? So we are using this prompt template here to generate that prompt, and then we are parsing to the model, and it is giving the right answer. If you see this, we have asked some question. John's brother is Michael. He has two sisters, and the question is, how many siblings does John have in total? So it is not only getting the answer, but also converting it into Hindi, right? All right. So now that we have learned about this, now let's see how we can build our YouTube application. So this is our YouTube video, right? This is an interview in this YouTube channel. You can use any YouTube video of your choice. And I have a bucket. And in this bucket, I'm just downloading the YouTube video. And then from video, I have to convert that into the transcribe. Basically, I have to take the transcript from that video. So I have created a utility function called utils. And it just converts, it takes that bucket which contains the YouTube video, and I mean, it will just take the URL and it will convert that video using transcribe, and then it will save it into the S3 bucket, right? So there is nothing fancy, and this is not about drag or our problem, because all we need is a transcript, right? So you can use any technique to get the transcript, and you can use the same code if you would like to. And then we are downloading it into our local machine. And if you see this, this is the transcript of our video, right? It's a 3 MB transcript file. All right. So if you see this, if I just open this file, transcript file, and see the first 100 characters, you will see that, this is, so it's able to read that question, right? So I think this is an interview with one of the European founder who moved from Europe to Gujarat, I guess, and he is kind of a millionaire, and I mean billionaire, and he's very happy about his career to IT. It's an interesting video. If you would like to watch, you may like to watch that. All right. So if you see this, if you now see the length of this transcription, it's pretty huge, right? So that the whole text is this much. Now, today, these models that we have, the large language model that we have, they are pretty, I mean, it can take a very huge context. I think somebody asked a question, right? What should be the length of this context? So in today's world, the models have a huge context size. And if you come to this AWS, this BedRock landing page and see here, I think you should be able to see the context length, right? Maximum token length. You see this is 200,000, 100,000, and all that, right? So it's a huge context that you can have. So in this case, the whole transcription can go in the context, right? So there is no need for RAG, in that sense. But imagine this video is for let's say 10 hours video, right? So in that case, the transcription of this whole text would be huge, right? So you may not be able to send the whole context along with the question. So in that case, what you have to do is you have to break that text into small chunks, right? So how we can do that? Again, we can use a LangChain. We can use a document loader, which will load the document, right? So here we are just using the document loader, and then we have to chop this document into small pieces, right? And the way that we can chop that document is using recursive character text splitter. So there are different text splitters which are available. This is a simple character-based text splitter, and it takes two parameters essentially, the chunk size and chunk overlap. I think somebody was asking, right, how we can define a chopping of the document. So this is how you can control. So what are these two parameters? Chunk size is basically means how much maximum the chunk size should be. And chunk overlap says how much overlap we should have between two consecutive chunks. So let's say the chunk size is 100. That means I will have the first 100 chunks, or let's say 100 words. And then the next chunk will start from the 80th chunk. Why? Because the overlap is 20. If the overlap is 0, then the first chunk will contain the first 100, and the next would be 101 to 200, and so on and so forth. But we should always have some overlap, because if you think about it, overlap will have the continuity of my whole text, right? So if you have ever worked in shift, you might have noticed that the morning shift guy doesn't leave, unless or until the next shift guy comes, and they always have some overlap. Why? Because the morning shift, the previous shift guy hands over the work that he was doing so that he get the context so that he can continue, right? So same thing, analogy you can apply here. So once you use any text splitter, in this case, we have used a recursive character text splitter, you can split the document, and then you can check, how that splitted document looks like. So if you see this now, this is no longer a plain text. It is a document object, and it's an array of document objects, right? And every piece contains some transcript, right? Like some information. Like in this case, this is all metadata. Yeah. So I think page content starts from here, right? So this is from here onwards, you get the page content. The initial few entries are around the metadata, and then the first line, and then the second line, and so on. So it has already splitted the data in different chunks. Okay. So now that we are done with this chunking, the next thing that we have to do, if you remember, we cannot use this text with the large language model. We have to convert that into embeddings, or array of numbers. And who will do that? We have to use some embedding model. So this is exactly what we will do. We now have these a chunk of documents. We will somehow convert that into embeddings, right? We will convert that into embeddings, and then we will ask some question, and this question will be compared with all these embeddings. So for that, question also need to be converted into embeddings, and then we will compare this embedding with all the embeddings that we have in the database or in our corpus, and somehow we will find the top 2 or top 5 or top 10 relevant context. Okay, and this is what we call as a similarity compute, how we compute the similarity, because this is not a relational database where we say select name, comma, address where employee ID is 5, right? That is not the search we are doing here. We are doing a semantic search, because it is not an exact search, right? And the way that this works is basically when we convert a data into vectors using embeddings, all data are saved in a very high dimensional space. So the way that you can think of it, let's say the embedding is just 2-dimensional, right? Just every word you convert into an XY plane. So let's say you give a word cat. So let's say cat is here. Then you give another word, let's say mouse. The mouse would be somewhere here nearby. But let's say the another word is computer. Computer has nothing to do with mouse or cat because these are animals and all that. So computer will be somewhere else in the 2D plane. And now let's say you do a search of, let's say, rat, and say that, okay, give me the top two similar words in your vocabulary. So I have three words, right? Cat, rat, and let's say computer. It will not go to computer because whatever I have searched, it's very near to this these cat and rat, right? So Matt's embedding will be very near to this. So that's why we use different techniques to find that similarity. So typically we used cosine similarity or Euclidean distance, which we just compare the angle between two vector embeddings or the distance between two vector embeddings. And that's how we find out this similarity. And you can actually, in the code, you can mention what similarity metrics that you would like to use, whether cosine similarity or Euclidean distance and so on, right? So let's see how this works. So let me first show you how this embedding works. For this, we can again use BedRock embeddings. And if I show you in BedRock console, in the models, you have seen this, I think I've just shown you. These are the embedding models that we have, right? So these are the 4 embedding models that we have. So we are using the Titan embedding model, which is the default model when we use here, right? So if you see this, I'm just using BedRock embedding. I'm not passing any name here, but you can always pass the model ID, right? And this model ID could be any of these 4 embedding models, right? 5 embedding models that we have as of today. All right. So now, if you see, I have the text. This is my question, like, or not question. This is just a plain text. Berlin is in Germany. And I just convert that text into an embedding. And I see that the embedding that I got is of length 1536, right? 1536. And you see this is an array of number. So in our example, it was just 2-dimensional, but this is 1536 dimension, right? So now if I ask one question, let's say we are not asking question, we are still creating embeddings. Let's say sentence 1 is welcome to Frankfurt. Sentence 2 is this is a table. See this is a table, has nothing to do with this first 2 sentence, right? Welcome to Frankfurt or Berlin is in Germany. These 2 are still very nearby, right? So now if you do a similarity search, right? And we use, let's say, a cosine similarity, you will find the similarity between welcome to Frankfurt and Berlin is in Germany is very high, right? It's almost 61%. But the similarity score between this is stable and Berlin is in Germany is around 26%, right? So that's how we find out which are the similar context when you throw a question, right? All right. So now that we know how to create embeddings, we have to store that embedding. So what we have been doing is we are just creating these embeddings, right? And we are just storing in variables, right? But this is not idle. So we have to store it in some vector store. So now let's see how we can store it in a vector store. So we have already created an Aurora database initially, right? We have seen that. And we already have enabled PG vector. And the way that you create enable PG vector, we just have to run create extension vector. That's all. Okay, nothing much you have to do. After you create an Aurora cluster, which is completely serverless, you can just create extension vector. And if I can show you this, this is the first step that you have to do. And once you do that, I have just connected to the database, right? So, through this client, a DataGrip client. And if I run this, you will see this. The current database is Postgres, right? This is the default database. But I already have this extension. So my Aurora database can now store vector embeddings. All right. So now how we can get started? So at this point, what we will do is we will again use PG vector to create the embeddings. So what we have to do? We have to create the embeddings and then store it, right? Creating and storing. In the previous example, when we were just One second, what happened to my mouse? Just give me a moment. Okay, yeah. So if you see here, in the previous case, what we have done is uh, we were creating this embeddings, right? We are creating this embeddings. So now we will not do this manually. What we will use is we will use LangChain. So in LangChain, we have a class called PG vector, and PG vectors, you just have to give the Postgres details. In this case, it's Aurora. So this is all these environmental variable we are getting from our environmental file, and that's it. And then we create a PG vector object with our collection name, right? This could be any collection, any name based on your project. So let's say introduction to RAG I have given. So you can think of it as a namespace, and you give all the configuration details of your database and what embedding you want to use, right? So I want to use BedRock embedding, which is the Titan embedding by default. And this is where you can define what is the strategy to find the similarity search. And here we are using Euclidean distance, but you can always have different techniques, not just Euclidean distance, right? So I guess uh, so if you see this, you have Euclidean distance, you have cosine similarity, and so on, right? So you can always use any of these metrics, right? That's all. And now, if you throw some text, see this, now I'm not doing every text embedding one by one. I'm just adding all this text together, right? So add text, and I'm saying that, let's say few text sentence, color of this bird is red, the cat slept by the fire, and so on. And then if I ask a question, I can simply say vector store one. This is the object, right, which we have created, right? And same object we are adding a text in it. Same object we are using to do similarity search. So here I'm saying, okay, give me some context for this question. What the bird was singing, and we are saying k equal to 3. That means give me the top 3 similar context, right? And if you see this, the similar context we are getting is this, right? I think one of the reason that we are getting the same thing 3 times is because I have run this notebook multiple times. So the same data got added multiple times on the database, right? So that's why this sentence got added 3 times, right? And it's kind of, that's why the top 3 giving the same 3 results. But if I just delete everything in the database and start it again, you will not find 3 same entries. You will first probably find this one. The second, you will find something which is more similar to bird. So my guess would be you will see this one, the cat slept by the fire, because you have cat in that, something like this, right? So anyway, so we got to know how we can store it and ask questions from or get the context from the database. So at this point, we are now ready to uh, go for our application, which is the YouTube application, right? Where you have the transcript and we can ask questions about the YouTube video. So in this case, uh, what we are going to do is we are going to ask a question, right? And it will first go to the vector database, get the context, and then with the context and the question, we have to create the prompt, and then we know what it has to do, right? It will just go to the model and ask, send the query with the context, and we will get the response, right? So the way that we will do this is we can just say vector store as retrieval, and then we can ask the question. Again, you are seeing the same answer because in my database, I have executed this notebook multiple times. That's why we get the same answer, but you will not get the same answer, right? So let me now go over this, right? So in this case, we are going to use LangChain runnable parallel and runnable pass-through method. And why we need this? Because if you see this here, when we give the question need to be sent to the retriever as well as the same question we need to send to the prompt, right? We need to send the same question to the prompt, but prompt need to wait till it gets the context, right? So how we can do this? We can do this using this runnable pass-through, which will just take the question, whatever the user asks the question, it will take the question and pass that question along with the chain without any modification. And the only thing that it will do is, it will take that question, send it to the retrieval to get the context. And also, once it gets the context, it will take the question forward to the chain. Okay. So let's see how this works. Okay, so I'll just quickly go down and run it again. Okay, this is our YouTube example. So now it's very, very simple, right? So what we are doing is we are creating this vector, PG vector. We are using the same PG vector, but in this case, our document is stored into in this transcribe file, right? So we are using the doc, right? So if you see this doc is nothing but this one, right? So we are loading our entire transcript into a loader, and then you are using a character splitter, which we have seen. So we docs contains all the chunks for my document. This doc, I'm sending it here. So what this will do is, it will take that document or chunks, it will create the embeddings, because I have mentioned the embeddings as BedRock embeddings, which is Titan embeddings. It will create that embeddings, store it in a vector database, and then we can simply ask the question like db.similarity search. And then we can ask some question like, okay, can you share the details of the speaker's journey from starting as a coder to becoming a successful entrepreneur, and all that. So now what we are seeing is not the exact answer. We are doing a similarity search. So in my previous, I mean, almost 1 hour back, we were giving an example that you asked me a Python question and I am giving you different books and telling you, okay, read chapter 1 to chapter 3 and all that. So this is also giving the context from the whole transcript. And this is giving you the top 3 context, right? So this is the result that you get of this top 3, similarity search. So it's a very long output, right? And if you see this, there are different contexts. So there is one context here, then another context here. So you will find top 3 contexts, because I'm just printing the first 3 entries. So we don't want that, right? We need to take this context and then ask the large language model. So this is exactly what we are doing now. We are creating this chain. Now we know what is chain. So we are getting the context. We are using the question as runnable pass-through, then prompt, then model, then parser. All these things we have been doing, for last 1 hour. And now when we ask a question, the same, any question that you want to ask, you can ask, like, what are the main challenges and advantages of doing business in India, including some, market sensitivity, price, and all that. I've watched this video, so I know that he has discussed these points. And now when you see this answer, it's mind-blowing, right? So you can see the challenges, advantages, and if you now watch this YouTube video, you will find that these are the things that they have discussed. And if I want to show you back into the database how these embeddings of our document look like, I can show you this here. If I come down to here, and if I just say, if I just run this command, right? So let's say this code, what we are doing, we are going to LangChain PG embedding. This is the table that we have, where the name is rag intro YouTube. And why this name? Because if you remember, we have used this collection name, right? This is the namespace. And if I run this, I'm just printing the first 20, because that YouTube video is huge, right? So it has the context of all, I mean, embeddings of all. So we don't want that. So if you see this, these are the text, right? These are the actual text. And this text are chopped using text splitter, which we have seen. And every chunk is converted into an embedding. And if you see this, if I just copy this embedding, right? If I let me copy this embedding, and the length of the embedding would be exactly same as what we have seen before, because we are using the same model. So if I just show you the length of this, see this, it's 1536. This is exactly same as the length of the embedding that we have seen, I think earlier. I do not remember where I've seen this. I think you can run through this notebook and find out the length of each embedding is exactly 1.5. Sorry, let me see this again. I think we should be able to see that 1536, right? Okay, yeah, I think I have deleted that cell, but you get the idea, right? So every embedding will be of size 1536. Okay, so that's how this whole things work in BedRock. Last thing that I want to show you, I think somebody asked about fine tuning and continuous pre-training. So in BedRock, it's pretty simple. You come to BedRock, click on Get Started. You have something called a custom model, right? And here you can create your custom model. It could be fine-tuned model or continuous pre-trained model. So let's do fine-tuned model. You can select any model of your choice which you want to fine-tune. And if you notice here, we don't have all the models for fine-tuning. Just few models are there for fine-tuning. So let's say we select Llama 2, right? And you can give some name. Let's say my Llama, and I can give some name. You should give some meaningful name, but I'm just giving some name. So here I have to give my training data, right? So I can give some random data. I don't know. I don't have any data as such, but I'll just choose some random bucket so that I can continue this to the next step. So these are just random S3 buckets, but you should actually give your valid S3 bucket name. And then you have to select some output path because you have to store the model in somewhere. So let's say I give some S3 bucket, because this is where your custom model output would be there. They choose the S3 model to store the model validation output. So this is where the output will be stored. And here you have to give some IAM role, because BedRock need to access your S3 bucket, right? So that's why you have to create some IAM role and click on create fine-tuned job. That's all. I'm not going to create that because it will cost money, and it will fail because it will find that these data sets are not valid, right? So but this is how you can create a fine-tuned job. Once it is created, you will find your fine-tuned model here. And after that, you have to click on provision it. Now it is already provisioned, but you have to provision it, right? And once that is done, then you can use this model. You can click on this model and you will get the model ID, right? So this model ID you can use in your SDK, where you have used Claude, right? So if you remember, if I scroll up here, we have used Anthropic, right? So in this case, you have to replace this with your fine-tuned model ID. That's all. Okay. So does this make sense? I think somebody, Piyush or somebody asked me about fine-tuning. Okay. So that's all I have for you. I think we are already surpassed the time. Um, uh, there is one small thing which I want to show you. If you allow me to, do you want to see that? There is a very small thing which is interesting called knowledge base, right? Which is whatever we have done, it's a manual thing, and it gives you more flexibility because you can select your database, you can create your embeddings and all. But knowledge base is something which will do all of this for you very quickly, right? So what you have to do is you click on knowledge base, give some name, right? Click next. Then you have to give your source data. So in our case, it was transcript data, right? So you can give, let's say, you can give your transcript data, whatever is the path. So let's say this is the path of your transcript data, and click next. Here you can select any model of your choice, which will be used to create the embeddings. And then you can create your own vector store, or you can just click on create quick vector store, and internally it will create a vector database for you, which is an open search database, not an Aurora one. But if you want to give your own Aurora database, you can select here, right? So let's say I just don't understand vector database and all that. All I know that is I have to create the embeddings and store it. So you just select the embedding model and the database, click next, and just click on knowledge base. That's all. Once you do that, it will take some time to convert all your data into embeddings and store it in a vector store. After that, you will have your knowledge base like this, and then you can easily question your database. So just like we have asked one question to the YouTube video and we got the answer. So we can simply first, let's say we can I don't want a response. Okay. So let's say I want to ask one question. So this data, this knowledge base contains all the Amazon stakeholders letters that Amazon sends to all the stakeholders, for last 20 years. So now if I ask any question, let's say, what is Amazon's strategy on generative AI, and click run. So if you see this, it has not given me the answer, but it has given me the context. So these are the chunks, right? Source chunk 1, source chunk 2, 3, 4, and so on, right? And you can actually tell how many chunks you want. So I have said 5. So let's say if I just modify this to 3 and ask the question again, I will just get 3 context, right? And now let's say if I want to get the actual answer, in that case, I have to click on retrieval, right? And I have to select some model. So this is the same thing which we have done in code, right? I just select, let's say Claude 3. And now if I ask the same question, it will get the context and then it will send to the Claude 3, and we should be able to get a reasonable answer. So it is now running. And if you see this, it gives us a nice answer with some hyperlinks of 3 contexts which were used to generate this answer. Okay, so I just wanted to give you, because we covered fine tuning, we covered RAG. I just thought to cover this knowledge base as well, because there is something new for developers who just wants a managed service to get started, right? There is something called chat with the document, which is even more easy. You just upload your document and ask questions, but I would not recommend that to get started with. I mean, you can always get started with this, but this will not give you much of an understanding of how RAG works. So that's why I just thought to spend time on the knowledge base, because you just saw how we can do this in the code and how we can do this in the UI. All right. So yeah, so that's all that I have for you. So let me just share you the GitHub links that we have. So first is, I would recommend you to go over this GitHub link. So it has everything around RAG and BedRock with Python. So this is the GitHub link. And today's notebook, what we have is here. Okay, so let me just, yeah, today's notebook is here in this GitHub page. So these are the 2 GitHub page that you can follow along. This is the notebook that we have gone through. And one more thing that I would like to share is there is a blog post which I have created. Yeah, this is the blog which covers in much more details what is vector embeddings and all that. If you are new to that, this is a 2-part series, and I'll try to share that as well. Community.aws, I think it should be my content. Yeah, I'll just send you the link and you can go over this. Yeah, so this is the link, right? So you can go over this whenever your time permits. Okay, I think there is a question from Ravi. What if we need the output of the query in some web application? We created the API of this in BedRock, used other applications. Yes, absolutely. So if you think about it, you can always use this. So if you see this whole application, we are just printing it here, right? Imagine that you are just invoking this in your let's say Django application or whatever. You can create any application of your choice in any programming language or framework. You can just take that response and parse that to your parser, and then send it to the end application, right? So everything is driven by API, right? There's nothing outside API. So that's the beauty of it. So you can always use this. And Okay, there is one more question, Piyush. What if we want to use OpenAI? Yeah, so OpenAI models are not available, right? Because they are kind of a competitor for AWS Bedrock. But you can use other models that we have. Right. So if you come to this base model, you can see all the different companies who actually creates different models like Meta, Mistral, and all that. And you can make use of these models. Okay. So one more thing is, I think we have not spent because the idea of this was RAG, but I understand that a few of you are very much keen to know about embeddings. I have one session, and I think in next 2 weeks where I will get into tokenizer. We will go in because I don't want to touch on top P, top K, all these things without telling you how we generate a word. When you ask a question, it generates a nice fancy answer, right? We have to think of that answer word by word or literally token by token. And when you understand how that one token gets generated and how the next token is generated, I think you understand how a large language model works. That was not the topic of the, of the day today. But if you're interested, I can host another session maybe here where we will deep dive into tokenization, how a transformer architecture or basically these models generates the token. So where we can get into the decoder architecture and BERT, maybe BERT would be a good example, and see how that embeddings were generated. Okay. All right. So, I think I'm way over time. I know it's pretty late if you are in India, so really sorry about that. But feel free to ask questions to me on LinkedIn, or you can email me as well. If you don't have my email ID, I can share it. So this is my email ID, or you can actually connect over LinkedIn, whatever you prefer, right? So, and we can take it along. Yeah.
Thank you, Suman. That was a great session. There are just a couple of more questions that are there. So if you have some time, just a couple of more minutes. If you
Yeah,
have...
yeah, of course. I have the
Okay.
whole day. Yeah.
So, okay. So Nikhil was asking that maybe can we use this notebook on a local system without the AWS? Is there a possibility?
Yes. So I'm using it locally. If you see this, I'm using locally, but the services that we are using are AWS services, right? So that's why you need to have an AWS account, and you need to use your credentials so that you can use BedRock, because BedRock you are using, right? So you have to have the AWS access. Let's say you don't have AWS access, but still you want to use this. In that case, what you have to do is you have to use some open source version of that. So in case of PG Vector, you can use some open source or free vector stores. Like, let's say, I think Pinecone you can use, or there are a lot of vector stores which are there, which has a community version. I'm not very sure, but Pinecone I have used. You can just create an account and you can use Pinecone just to get a feel of that. And similarly, you can use any large language model which is open source, and you can just replace the code. LangChain supports most of the models. So you can just replace BedRock with that. And once you are comfortable with that, you can create an AWS account and then use BedRock. So you can, the short answer is you can run it locally, and exactly what I'm doing now, but you need to have AWS access to use BedRock.
Okay, great. One more question from Ganesh. This is the last question that we are taking for this session. So in case of some open source LLM model, can I upload it here as part of the base model, or is it completely under the control of AWS Bedrock?
Okay, that's a good question, Ganesh. So what we have today is when you create any custom model, when you use a fine tuning or continuous pre-training, you have to use the models that we have the support for. Not all the models are supported for fine tuning. Like, for example, we have lots of base model, right? Here we have lots of base model, right? More than 30, 40 base model. But when it comes to custom model, when you click here and create a fine tune job, you just have a 1, 2, 3, 4, and 5, 6, and 7, 8 models. So if you use fine tune or continuous pre-training, you have to use only these few models. But there is something that we have recently come up with called import models, where you can import the model weights which we have trained somewhere else, and you can import it here, right? So you can simply click on import model, and you can give your model details from SageMaker or your S3, wherever is your model artifacts are stored, right? So these are the two options that you have, but you don't have the, let's say you want to use any open source model and come here and want to fine tune that is not available at this point in time. So you have to select the model that we support for fine tuning and continuous pre-training.
Thank you, Suman. So there were other questions from participants also. So I would request all the participants to check out our YouTube channel. We have been sharing the link for that YouTube channel there. Thank you, Suman, for sharing your profile. So you can reach out to Suman on his LinkedIn profile. And there is a link to a feedback survey that we have shared with you in chat. So we would like to thank all the participants for taking time out. More importantly, if you would see, so Data Couch is a community of people who are excited and passionate about data, artificial intelligence, and more recently into the generative AI space. So next week, we are also going to have another event, which is around generative AI for software developers on Microsoft Azure. So if you are interested in Azure and generative AI and their capabilities together, so you can tune into them. So that's it from our end. We would like all the participants to fill out the survey form. And more importantly, Suman, thank you for taking your time out on this weekend and making this event a great success.
Thank you so much. Thanks everyone for joining, and thanks for your time.
Have a great evening. Have a great day. Bye-bye.